sequence. So
Good afternoon all. We are going to start session 8 on emerging solution for environmental application. We are moderator Dr. Labhsetwar for this session. Dr. Labhsetwar is Chief Scientist and Head at Energy and Resources Management Division, CSIR-NEERI Nagpur. He has more than 32 years of research experience in environmental and energy. His areas of interest include energy and environmental material, air pollution control, heterogeneous catalysis, and shape-tailor catalysis, cleaner energy generation, water treatment and management. He has over 150 publications and 22 international patents. He has received 9 awards for excellence in research and also reviewed various fellowships in India and abroad. He is reviewer for more than 10 SCI journals and member of editorial advisory board for 2 international journals. He is involved in more than 15 R&D projects. Now I request Dr. Labhsetwar to carry the session forward. Dr. Labhsetwar.
A very good afternoon, and I would like to welcome all the panelists as well as all the participants who are online now to this theme 8, which will be focusing on emerging solutions for environmental challenges. So as we all understand, and the topic doesn't require any introduction, we have intentionally got a list of panelists who are from the different discipline related to the environmental engineering or environmental sciences. So as you must be eagerly looking forward to listen to our esteemed panelist, I will not take much time and would like to introduce you to our first panelist, who is Dr. Sukumar Devotta. And at the outset, very good afternoon, sir, and welcome to this session. And as a moderator, probably I feel the most difficult job for me will be to adequately introduce such an eminent personality, and whatever I'll try to say about Dr. Devotta should be considered as a very badly moderated introduction, very brief, and he's such a modest person who has also asked me to be very modest. So Dr. Devotta has done a chemical engineering BTech from University of Madras, and again then MTech. Then he did his master's from University of Salford, and later he again worked as a senior postdoc research fellow at the University of Salford. He has actually done a pioneering research in the field of energy and environment, contributed for several decades actually to the issues of environmental protection, one or the other way actually. And he has been deeply involved in the issue of CFC replacement, which is still a challenge, both nationally and more importantly, international levels. He was leading the Restoration Society of India, very actively involved in process engineering and development of many environmental friendly chemical and environmental processes and technologies. He's very widely consulted by Indian and international agencies, including UNEP, IPCC, EU, GE, GIZ, just to name a few. Under his illustrious career, he has served a very prestigious National Chemical Laboratory in India at different positions. He was heading the process development division. And later on, he became a director of CSIR-NEERI, where he has so many accolades to mention. Very few things I'll mention about him. Recently, we remembered him because he was figured in the world's best 2% researchers as per the list by the Stanford University. But probably more illustrious is the Nobel Peace Prize 2017 to IPCC, where he was one of the very important member of IPCC. He has got Environmental Leadership Award, CSIR Technology Award, which we all consider very competitive and prestigious, ICICI Technology Award, US EP Award, to just name a few. He's an honorary visiting fellow to University of Salford, England, which university still recognizes him as one of the very prestigious alumni. And he was given the Sulfur Alumni Achievement Award 2017. So Dr. Devotta has not only publications, he has so many editorialship to his credit, many important patents and inventions to his credit. So I'll just stop here and just brief you that his areas of specialization is quite wide, right, from chemical process engineering and development, environmental science and engineering, especially wastewater and environmental impact assessment, industrial energy conservation, alternatives to CFC, HCFCs, HFCs, and global environmental policy and protocol. So one of the most respected name in the domain of environmental engineering. We have a panelist with us, Dr. Devotta. So I would request you to kindly go ahead with your talk.
Okay, thanks, Nitin. In spite of my request, you have exceeded time limit anyway. So I would like to thank International Society for Energy, Environment and Sustainability, and particularly Nitin Labhsetwar for giving me this opportunity. I chose to speak on uh, industrial wastewater treatment, uh, zero liquid discharge. I just wanted to. So pros and cons, because this is a very challenging area, meaning that how do you treat water, industrial wastewater, and then reuse it in the same plant is the current dictum. So it's not easy, it's not cheap also. So I just chose this topic because I've been involved in this area for about last 12 to 13 years, and particularly with respect to leather industry. So my talk will have this outline just for a brief. What is environment? What are the environmental issues in leather industry, and what are the directions by CPCB, Central Pollution Control Board, for tanneries? What does ZLD mean for tanneries? How do you manage the reject, RO reject? How do you recover salt and reuse it if possible? And what are the future challenges? Uh, the leather sector is considered to be one of the polluting industries by CPCB. It is one of the highly polluting 17 industries uh, categorized by CPCB, and the leather involves a lot of cleaning, particularly skin removal, salt used for preservation, now dehairing. Then you also have a chrome tanning we used to have, and we still do. So it involves a lot of chemicals and salts in the process, and therefore the wastewater becomes highly, uh, you know, laden with salt and chromium. In the past, they have not taken appropriate care, I would say. And in the process, a lot of areas where leather industries were involved, where water was polluted, and the there was one case of Tamil Nadu where court directed the leather industries consortium to pay rupees 30.5 crores in 2002, which was a lot of money. And then Pollution Control Board put a limit that you can't discharge water more than 2,100 milligram per liter, which means the TDS has to be within that. And it is not easy because TDS of leather sector anywhere will be above 5,000. So that means you have to take care of the TDS. And even now, very close to a couple of years ago, 11 in tanneries were closed in Trichy because they were not complying with some of the demands, the regulations imposed by CPCB. And the government of India also keeps on giving directions. Like there was a charter on corporate responsibility for environment protection, what we call as CREP, which was introduced in 2003. And then in 2019, the Ministry of Environment, Forest and Climate Change kind of revised standards and gave some guidelines. And then 2019, the CPCB gave revised guidelines and saying that you should improve, otherwise you have to close. And having said that, the government also has come out a lot in their help, because there is a scheme by which the government is giving 80% of the budget and 20% comes from the industry, and with this they are able to uh, implement some of these challenging things. The improvements are saltless picking. They don't use salt in some places, and enzyme deliming or skins. That means the hair is removed by enzyme rather than by any chemical means. So you don't use any chemical. Chrome recovery. Virtually 95% of the chrome is recovered and reused in the tannery. And now the issue is zero liquid discharge. ZLD in India is becoming kind of a, it started with Tamil Nadu, but now it is virtually going across pan-India, because I have visited quite a few ZLD in Ganga Belt. Now all Ganga Belt industries are being told that you must implement ZLD, and several states, particularly Tamil Nadu, where it is water starved, they are saying that you must implement ZLD. So you cannot expand or even continue certain industries unless you implement ZLD in Tamil Nadu. And so, therefore, they have made it obligatory. And the CPCB made it obligatory for Ganga Belt. And so it's felt that slowly all industries will fall under ZLD. Tamil Nadu, there are two major industries, tanneries and textile. What is ZLD? ZLD refers to the recovery of water and not to let out any water, but only take water for makeup. That means if you are given consent for 100 originally, now you can take 5% of that water, and 95% of the water you should be able to recycle. And you cannot also discharge any solids. That means if there are salts there, you have to recover the salt, either reuse the salt or get rid of it through TSDF. And so this is not easy. I must tell you, this is not easy. The tanneries in India are located mostly in one district called Vellore district. And it is, I would say, about 60% of the Indian leather tanned in India, they come from, 60% comes from this particular part of Tamil Nadu. And therefore, it's highly concentrated, water intensive, so there is likelihood of pollution, which was there in the past. I myself have visited as a member of Supreme Court Monitoring Committee many plants. So this is a big challenge, but now they have quite a few CETPs operating, fully complying. The main part is, I told you, the main concern is this. You know, if you take raw tannery effluent, although the CPCB standard is 2100, you start with something like 15,000 at least. So it's way above 2100. How do you deal with that is the main issue. There were many discussions. Can we discharge into sea or dilute with municipal sewage? These were discussed, but these are located, I told you, in a remote place where even sewage is not available in that quantity. Therefore, it is not feasible to think of dilution with sewage. And second, seawater disposal also is not possible because it's at least 100 kilometers from sea. So ZLG is the only solution if they want to survive. And one plant which I've taken, I've been involved with this plant even as the director of NEERI. So it's more than 14 years I've been associated with them. It's a model CETP, I will call it very iconic. And you can see that the CETP is connected by various tanneries. These blue dots are tanneries, and these tanneries are located across highways, roads. So these are all highways. Now you can see that tanneries are located across highways, and the ETP is located here. So they have to transport all their waste water to this by laying roads. So they have laid something like 15 kilometers of roads, pipelines across roads and transporting wastewater. That wastewater comes with pre-treated wastewater. It's not a raw. The pre-treatment is given in the plant itself. If they can't pre-treat, they cannot send it to CETP. Then rest of these things are more or less the same. You go to any ETP, you will have primary treatment, secondary treatment, to some extent tertiary. But then this ultrafiltration, reverse osmosis, reject management, they are all part of the ZLD. So these are the pre-treatments in one particular building. You can see that they are already pre-treating, and the pre-treatment is monitored online. So if they don't comply with that, they cannot send it. They recover water. Almost 95% of the water is recovered by treating with magnesium hydroxide, and they get it as a chromium sulfate, and then they use it back in that. And the CETP involves almost similar primary and secondary, I would say, but there are certain minor extra things like chromium recovery. Even little bit of chromium comes out. That has to be recovered in the primary and secondary treatment. And so there are some dual made of filter. You may have fat and things like that. So you need organic scavenger. All those things are there. And the most important part, once water is treated, you get into ultrafiltration, because there are still minute particles which have to be removed. And this ultrafiltration is done by using PVDF membranes, and they remove only suspended bacteria, coli, and small particles, and that treated water is sent to RO. This is a reverse osmosis membrane. I wonder how to, yeah. Okay. So RO membrane is a polyamide spiral bound. So you can see that they are all spiral and horizontal. The previous one was vertical. And people generally, industry uses two-stage RO. The first stage is low pressure. Low pressure means it's not that low, 33 bar, where you get about 45 to 50% water recovery. Then followed by second stage, which is 60 bar, you get another 15%. So you get 25%. So you get 75% recovery from RO primary stage. Then you have high pressure RO. This high pressure RO is now operates around 95 bar, and now there are technologies available which operate at 120 bar, because with 120 bar you can recover more water. That's why it is likely that the CETP will change over to 120 bar RO to boost the higher recovery of water. When you recover more water, you get more concentration in the reject, therefore less energy required in the evaporation. The evaporation is the most difficult part, which is not familiar to even wastewater treatment specialists, because this is more of chemical engineering unit operation. So that's where I got a lot of involvement in the CETP, because having done thermal engineering in the early part of my career, I got into this to mentor how to deal with multiple effect evaporation. What we do is, we use steam to evaporate in the first effect. Then the vapor from this is used in the second effect. Then the second effect to third effect to fourth effect. So you have a four effect, falling film evaporator, because it's made of steel. Therefore, it's very expensive because you're dealing with concentrated salt solution. Therefore, you have to use steel, duplex steel, to avoid corrosion. Then we have three effect force circulation, because by this time the concentration becomes very high. You cannot use falling film; it will not fall at all. So you have to have a force circulation. Then force circulation to centrifuge, where you have the magma, that is concentrated salt solution, is filtered through a centrifuge, pushed centrifuge, and then you get the salt. Salt is dried, and in some cases they use thermo vapor compression or multiple mechanical vapor recompression, compressing steam from third effect to first effect. So that means you only do some, you save steam consumption in this part of the evaporator, and because you have to save steam, because steam is one of the major expenditures in the whole process. And this is installed, made of steel SS 304 or 316, and it's very energy intensive. It's very expensive also. Just a picture of this. And you recover salt. The salt is not pure because there are two kinds of salts used: sodium chloride and sodium sulfate. So sodium chloride comes mainly for conservation, pure preservation. So, this recovered salt now is stored under lined shed. In this plant, there are 26,000 tons of salt stored because they don't know what to do with the salt. The Pollution Control Board is saying that you have to get rid of it through TSDF. Now, TSDF will charge at least 3,000 rupees per ton. So you can imagine the cost involved. So we are now trying to purify the salt by redissolving it. And there are some patented processes, but one such process is by CSR, CSIR-NEERI Bamnagar. They have a proprietary technology. We are working with them to purify the salt. This is only purification of the separated salt. But we are also trying to find out whether we can purify the salt in the evaporator itself. With that, you can avoid double cost of getting the salt and then again dissolving it and purifying it. The ZLD cost is pretty expensive. Now, if you're today, people are an average wastewater treatment in the industry, just with ETP, may be spending about 100 to 200 rupees per ton per meter cube. But here, they are spending about 800 rupees per meter cube. So, it's additional cost is very, very high. But there is no other go because it's not viable. We know that it's not sustainable also. But then the industry cannot survive until they do this. At the same time, government has subsidized this capex by giving them 80% subsidy. The challenge for CETP is how do we minimize the cost? If there are any wastewater technologies listening to it, I would appeal to them, look at minimization of the cost. In ZLD, you are in for a very big business, particularly the recovery of salt and reuse of salt. That is one. Second is most of the cost to the member of the CETP is charged by volume basis. Now they have, people have started conserving water because they have to pay for it. So instead of originally when they started, they were almost using 30 liters per kg of leather. Now with the conservation, they are only using 8 liters per kg of leather. But at the same time, they dissolve same quantity of chemicals. That means you get much higher the TDS. Now, when they started the CETP, they were getting around 10,000, 15,000. Today, it's excess of 30,000, 40,000. Your biological system will not work under high TDS. So again, if you're a specialist, you should find out how do we deal with high TDS for biological, how to make it amenable for biological activated sludge treatments. So I've come to the last stage. ZLD is important for the production of scarce water resources in the Vellore district. I'll tell you a joke. Vellore district has a river. In the last 15 years, I have not seen water. This year, because of the copious and torrential rain, people came from far off villages to see water flowing in the Pala River. So with ZLD, this is a blessing for them because they are saving water from the being consumed by industry. But it's still expensive. The focus of the R&D should be um, how do you reduce the cost, and most important thing is what do you do with the recovered salt? If you can purify it so that it can be given to some the fluoroalkyl industry. So that's all I wanted to say. Thank you very much. I've taken a lot of material from my industry friends, the Rani Tech, which is the CETP, SEMCOT, which is the agency managing CETPs in India. Aishma is a leather body, ILIFO is another leather body. I've been involved with them in the last 40 years or so. So I'll be happy to answer any question. Thank you very much.
Thank you so much. And I truly appreciate for concluding your talk well in time, despite the fact that you have explained a real world problem through some case studies. So it's it's been very, very useful for us. And I can see now more than 100 people joined online, and there are quite a few students also. So thank you very much for explaining the process of ZLD, which is becoming pretty common and much talked about. And as I can see that there are multiple processes involved in this, right from filtration to thermal to evaporation, and of course the RO. This is pretty heartening to see that RO, we can achieve up to 85% of recovery. The best part is there are many young minds here. And as you rightly pointed out and encouraged them, that there's a lot of scope of innovations to go in this process. I think as you need to leave, I have received just 2 questions. So you can quickly possibly oblige them by answering, and then we can try to catch you during the discussions. One is whether LCA would be a good idea of this process vis-a-vis other process. And the second question is, can we think of using the recovered evaporated water that might be still significant, about 30% or so? So these are the 2 queries from.
Yeah, okay. LCA, you can apply either to leather or to the process, but we cannot apply to a process because it is imposed by a regulator. So we have no choice. But for the leather industry, LCA can be applied. But then if you want leather, there are certain things inevitable. So some of the things in the past which people have used, chromium, for instance, was the major source of pollution from leather industry. But now chromium is virtually gone. I can show you water, recovered water. You can drink it. It's like this. You can drink. It's like that. But the second question is what was that?
Second is, can we use this recover and use the evaporated water?
Of course, the 98% recovery generally reported in top CETPs includes steam and steam condensate. So we count when I do water audit. I have to do water audit for membrane section and water audit for evaporator section. Then water lost through sludges. Most of the sludges are minimum 5% moisture, but sometimes you get 10% moisture. So when you do audit, you are able to recover 98% of water, including steam. And but you don't send it back to boiler because it may contain a little bit of ammonia. So we only use it for it's sent back to the tanneries. So we have a wastewater conveyance pipeline and recycled water conveyance pipeline. So they are totally 20-kilometer pipeline laid across the village. That's it.
Thank you so much. And thank you so much for encouraging the researchers to come forward and taking up this thing. I would like to formally thank you so much for sparing your time despite the very busy schedule, and thanks a lot. And if possible, we would like to just give a ring around 5:30 if you can join for 10-15 minutes.
Thank you.
Right.
Thank you.
Thank you very much. Okay. So, ladies and gentlemen, we'll move to the second talk of today's session. And we once again have an eminent personality who has got a excellent blend of both academic and the field experience. He's a proud Indian who is now doing an excellent work in the area of water and many other environmental processes in the UK. And it's my pleasure to briefly introduce you Professor Anil Kashyap, who is head of the Department of Geography and Environmental Management. He brings along with a wealth of national and international experience of more than 22 years in, as I mentioned, academia, research and public center. Prior to this, he was a head of school at Coventry University and professor and director of School of Real Estate at RICS School of Built Environment. He holds a bachelor degree in civil engineering, master in urban planning and PhD from University of Ulster, UK. Dr. Kashyap is a chartered member of Royal Town Planning Institute, RTPI, London, member of Royal Institution of Chartered Surveyor, London, and fellow of the Institution of Town Planner, India. He's also fellow of the Higher Education Academy, UK, and a council member of the International Federation of Housing and Planning, representing India. He has recently been appointed to a prestigious panel of International Land Measurement Standard Setting Committee, led by RICS London. So Dr. Kashyap has a very strong research interest spanning from energy efficiency in built form, which is gaining too much of importance now. Healthier smart cities, urban generation, and infrastructure development and financing. And you can imagine that these kind of topics are very, very relevant in the Indian context. And he has got a very strong link in India, as I understand. Dr. Kashyap has key strength in strategic urban growth through his international experience. He has been involved in a wide range of research projects funded by various agencies, research councils, charities, and international institutions. He's contributed on a major research project, namely urban security, Be Secure, which is commonly known as, funded by the EU under the FP7 program, public-private partnership funded by the RICS Education Trust, and urban regeneration and energy efficient building research. So he has quite illustrious career, and he has been very active, as I mentioned, to both the academic world as well as the research project by the international agencies. So as I can see, a lot of administrative responsibilities at the universities. So his core area of expertise are low carbon green buildings, which is a very hot topic, as we all understand, energy and urban form, urban regeneration, smart cities, real estate, PPE infrastructure development, investment and financing. So with these few words, it's indeed a pleasure to have you, Professor Kashyap here, and I would request you for your talk.
Thank you very much, Dr. Labhsetwar, for generous introduction. Let me try and share my screen here. Zoom. Yeah, it's now able to share. Is it visible?
Yes, you can go to presentation mode.
Yeah. So thank you very much again, the ICES, for organizing this very interesting and pertinent discussion around energy and environment and sustainability. This is so topical and very close to what normally people these days are increasingly recognizing this as an environmental challenge. Environmental challenges are around climate change, environmental degradation, unsustainable consumption, pollution, resource scarcity, and a number of impacts on people around the world. So my presentation today is around emerging solutions for environmental challenges.
Mr. Kashyap, sorry to interrupt. You can go in the presentation mode or PPT mode. It's still.
Is it? Is it just only the icon? I can see.
You are seeing as a presentation mode?
I'm seeing as a presentation mode here.
Okay.
Let me again try and share. Is it?
Yes, perfect now.
Sure. Thank you. So what I was talking about was setting the context of the session here, which is emerging solutions for environmental challenges. And you can recognize that there are a number of environmental challenges around climate change, etc. And various countries are so under tremendous pressure how we can deal with some of these environmental challenges. And there have been scientific discoveries as well, and help from the research and scientific community to address this this major issue around environmental challenges. There is a growing need for some of the innovative solutions we should be looking for. And my talk will be covering some of those innovative solutions which are under research, and some of these are under implementation as well. Let me start here with this most familiar face in the environment field. Here is a young champion, Greta Thunberg. And Greta is it's a young girl from Sweden, and is advocating environment and climate change, and the action which governments are taking so proactively. And she was here in this summertime in Bristol as well, protesting along with the number of people advocating environmental climate change and some of the agendas by various governments. So it goes without saying that what Greta says, that we are speeding in a wrong direction on climate crisis. So you can see the concern of very young people who are really worried about the future they are coming into, and it's not a small thing. So it's not easy to comprehend at this age that how climate change and all that happens, but lots of young people, they are very much involved into the discussion and debate, and that is what is required. Sustainable development goals. Sustainable development goals were adopted by all United Nations member states in 2015. And these are 17 sustainable development goals, and a number of these are addressing and are trying to address the same kind of question, which is the title of the presentation is Emerging Solutions for Environmental Challenges. And the key environmental challenges which are listed, I have listed few of them which are more key to in today's context, is around infrastructure resilience. The climate change has a lot of impact on infrastructure. And for example, if you have the flooding, if you have the climate events which are impacting our infrastructure. For example, in Mumbai, the floods and various road blockage, road infrastructure, and even the housing because of the hurricanes, etc. All those are impacting onto the infrastructure. So that is one of the area of concern and a challenge, that how scientific community actually can help and research community can help in building the resilient infrastructure. And number two is on poverty and natural resource management, such as food security. Food security and water is coming on the top of the agenda here because of you can see that the hunger, and one of the sustainable development goal around hunger is very prominent, and one of the another sustainable goal around the water is also quite a significant one. So this is another challenge, environmental challenge around food and energy and water nexus. So we call it as a food, energy and water nexus. Life cycle approaches to resource efficiency, which Professor Devotta has already highlighted number of things around number 3 here in his presentation. And then finally, innovative sustainable business developments. It's so more about businesses. It is not about processes, but it is about businesses. Dr. Devotta has also indicated some of these, how the sustainable business and how that recovery of salt, etc., can be actually positively utilized. So I'll be talking about in next 5 to 10 minutes around these topics and some of the emerging solutions. So the first one is which I will elaborate is around use of artificial intelligence. Normally, when we consider energy, environment, sustainability, we keep ourselves in a domain where we are more focused to our own domains of engineering around environment, around climate change. But we need to build and go multidisciplinary, and that's where this artificial intelligence, cloud computing, blockchain concept. So trying to for environmental scientists, it is quite key to understand the use of some of these technologies. So artificial intelligence is one which can actually help in number of ways, and I'm giving one example here in this slide is around Excel Energy. This is one of the energy production company called Excel Energy. They use artificial intelligence in their smokestacks. So you can see those tall smokestacks as a part of energy production, the thermal plant or the power plant. And artificial intelligence actually it works like a human brain, and it uses neural network kind of mechanism. So it captures, artificial intelligence captures the information around the NO2, nitrogen oxide, and the carbon emission or the carbon content, and it then sends the message back in the furnace and the use of material, and it actually changes the composition in such a way that the emission level is within controlled limits and prescribed levels, which can improve the sustainability. So it's quite a clever way of using artificial intelligence rather than having some sort of manual or sort of mechanical way of analyzing some of the things. And this is immediate, this is very quick response to the change in the emission levels, etc. So that's one area which I'm highlighting, that environmental challenges can be actually solved using the innovative and multidisciplinary involvement around artificial intelligence, cloud computing, blockchain concepts. The second environmental challenges around food, which I just mentioned, and food and water. Water is quite scarce. And there are a number of ways we can actually use Internet of Things, IoT, which is again emerging technology, sensors, etc. For example, in this picture, you can see some of the sensors which are embedded into the soil to monitor the soil moisture and the local weather conditions. So once you have this kind of sensors and local weather conditions measured here, then you can actually devote whether there is a, what kind of level of water requirement it has got, and then you can actually target those water cycles in such a way during the year that there is a water conservation. The number two here, which I'm looking at, is again relating to carbon capture. So drones are being used to model the forest rainforest covers, and gathering information about tree health, gathering information about heights, biomass, the green cover. And then by using the technology 3D model, you can estimate that how much amount of carbon this forest can actually capture. So carbon capture is another area which is quite of a significant challenge, and using some of these technologies, you can actually real time identify that what level of carbon capture can be possible in a particular catchment area. And the finally is again IoT sensors. I said in first bullet point here, if you can use those for measuring and monitoring the moisture content in the soil, or in any of the irrigation plantation where water is quite scarce, and for example even the orchards as well, you can utilize these innovative technologies to solve some of the environmental challenges. And to without undermining the role of circular economy, I'm trying to indicate to this as one of the emerging solution for these environmental challenges, is looking at the sustainable consumption and production mechanism of solid waste is produced, and solid waste is a challenge for everybody. That's the reason that about 3 to 3.4 billion metric ton of solid waste is generated worldwide, which is huge increase over last number of years. So this concept of circularity, which aims to reduce waste by reusing, recycling, and reutilizing it, is gaining a bit more popularity around it. So so this is one other area, and a huge area for research as well as for implementation around sustainable solutions for environmental problems. So to summarize then, in terms of what I was trying to give as a message very briefly in 10 to 15 minutes, was that there is a rapid change of technology. And we as environmental scientists and environmental engineers need to be really open up to these huge and vast set of opportunities which can actually help and generate long-term sustainable solutions and values for us. And we need to support innovative businesses in these models, and we must invest into some of the data sharing. So there has to be an environmental data repository, so we can actually then share all that environmental data. And institutions like NEERI are so well placed in having a repository of this whole data, and then utilizing is data in research and implementation, and even for business ideas generation, etc., and help the citizens in making number of decisions, or cities, all those stakeholders. So we need a platform and institution in order to have this kind of capability, and then that's where the team around the table from NEERI is one of the best, very very appropriately placed in order to progress this as an agenda forward. So I'll finish my talk here, and I'll be happy to take any questions later on when panelists are finished with their own presentations. Thank you very much.
Thanks a lot, Professor Kashyap, and I once again appreciate you also for maintaining the time so that we can have some time for the discussion. It was a very impressive talk, especially in the context of the futuristic areas which are becoming more and more relevant. And I can see that even in the Indian context, where the urbanization is taking place probably at the most rapid pace, these issues become very, very handy. And also, thank you so much for introducing the applications of AI and other tools like IoT, okay, which are the talk of the time to environmental challenges. Circularity is another thing probably which will be very, very useful for developing countries like India. And commenting on the repository, yes, I'm very happy to share that NEERI and specifically our director, Dr. Rakesh Kumar, has taken an initiative, and in-air repository has already been launched for air pollution data, and probably soon we are going to add to other environmental issues. And there have been a lot of addition and very large number of users, in fact. I would also be happy to share with you that you have, in fact, introduced to some of the fascinating applications of the drone and the sensor and IoT, and my own colleague in our group have already started working on that very, very actively, and I'm sure they are going to get connected to you. And drone is becoming so popular that in the rural areas, the farmers have started monitoring their crop even for the pest control, and it would be a brilliant idea to go further. So I would like to thank you so much and for this very, very informative talk. And we'll have time for the discussions once we are done with the presentation. So thank you so much.
No problem. Thanks, Nitin.
Now we will quickly move to from the wastewater to the urban environment. Okay, we'll move to listen from Professor Shirish Sonawane. Professor Sonawane, are you there?
Yes, I am there, sir.
Fine. Good afternoon and welcome to this session.
Good afternoon. Thank you.
So Professor Sonawane is one of the very bright faculty of very well-known NIT Warangal. He belongs to the Chemical Engineering Department of National Institute of Technology, we call it the Warangal. So he obtained his MTech in Chemical Technology from MS University Baroda in 1999 and PhD from North Marathwada University, Maharashtra. And his PhD was on studies on mechanical and rheological properties of polymeric composite reinforced nanoparticles. Then he joined NIT as associate professor and established a mini center of excellence in sono process engineering. He worked in the process control laboratory at University of Dortmund, Germany in 2002, and then University of Melbourne, Australia, and then Portugal. So he has got good international exposure and international program he was part of, including many international projects to his credit. As an academician, he has guided so many MTech and PhD. He was very modest in writing about this thing. His H-index is 23, but more than that, I personally know that there are so many processes intensification he has done, as well as he has done great work in the field of use of sonochemistry for the water treatment. Published more than 100 STI journals, 25 book chapters, and 17 patents, as I have mentioned. And he has guided several PhDs. He has undertaken research activities in the quite a frontier areas, I would call, like sort of process engineering, cavitation-based nanotechnologies, which is becoming again very popular as a energy efficient technology, wastewater treatment, process development for nanoparticle synthesis, polymer nanocomposite, to name a few. So with this few words, I would like to first sort of mention 2 or 3 more things. Like he was awarded a prestigious Bioscast Fellowship from DST, and then the Heritage Fellowship from Erasmus Mundus program, which is very, very well known from the EU or European Union. And he also got a Young Scientist Award from DST Government of India, part of many editorial board member. So we are indeed very, very happy to have such an eminent academician with us. And with these few words, I would like to request Professor Shirish Sonawane to please go ahead with this talk.
Thank you very much, sir. I am now just sharing my PPTs. So can you share my screen? Can you see my screen now, sir?
Yes, it is perfect, and your voice is also very clear.
Yeah, thank you very much, sir. So today I am going to discuss about how cavitation-based processes can be implemented in wastewater treatment system, specifically for industrial wastewater and the the urban wastewater treatment. So there are some things I need to brief it. So ultrasound cavitation, this is basically comes under the advanced oxidation processes. Maybe you say Fenton process. Maybe.
May I request others to please mute their mics so that Professor Sonawane can go uninterrupted? Thank you.
Yeah. So this is basically cavitation-based processes are the part of advanced oxidation processes. Basically, when you are using ultrasound probe during the reaction mixture, it will generate the radicals OH dot or H dot based on the what is the solution content. So using this methodology, ultrasound cavitations we can implement at a laboratory scale, but hydrodynamic cavitations we can use it onto large scale in a pilot scale also. So when cavitation is going to be happen, basically 60% of energy usually been lost. Sorry, 40% of energy usually been lost in during when you are using any pump to get the liquid out from the pump. So this can be if you used venturi or maybe orifices in the same pipeline, it is generates an cavitating bubbles actually. These are very powerful in terms of generating the radicals, and these radicals we can utilize for the reactions to be degrading the components. So here I'm showing you a hypox process. Basically what found is generally when single methodology cannot be useful to degrade or complete mineralization of the components. So usually one or two methodologies generally been combined. Here it has been shown ozone process along with an hydrodynamic cavitation it has been used. Whatever we use an ultrasound reactor, it is basically acoustic kind of cavitation. So the combining this methodology, these are the all commercial setup what I've been shown in the picture. So electrochemical uh, process along with the cavitation also we can implement in the industry. Here is an ozonex is one process which has been shown over here. So basically initially hydrodynamic cavitation has been used as a making the mixing, then it generates the radical, some partial components have been degraded, but again the next methodology used is an ozone process through which combination of, so it is called as an ozonex technology. Basically again it is part of the advanced oxidation process. So exactly in this process heavy metals and the bacteria that can be killed. Okay. uh, for example, in the microbial growth there is always a single cell structure, and because of high impingement of cavitation, these are going to be degraded, and with an ozone also this remaining part we can mineralize the process. So bioelectrochemical process is also there. Usually, what it is called as a microbial fuel cell. This is also upcoming methodology to degrade the component and use that water also and generate a small amount of energy. Basically, the microbial fuel cell, which is how these structure like usual chemical fuel cell, and we can disinfect the water as well as the wastewater, the water we can effluent we can utilize that one. Here you can see some small amount of gas is also been generated, as well as this water, we treated water we can recycle and reuse. So this is again one more possible methodology. But generation of hydrogen, this all these things have been on bioelectrochemical processes are working on the laboratory scale. It has not been much implemented onto the large scale. But in the future, this is the methodology which will be going to be useful for the treating the wastewater. So in advanced oxidation processes, maybe have number of combination, ozonation, UV with hydrogen peroxide, or photopenton, photocatalytic, or sonolysis. These are the some of the uh, these advanced oxidation processes can be implemented. Chemox is one more methodology. Here the in the ozone is being utilized for the to degrading the component. Along with that membrane it is also been utilized. So this is one more methodology has been shown, ozone generation as well as some impinging reactor uh, we can utilize to make this combination to get the degrade of the wastewater. Photocatalytic system, if you use, there are currently been said that there are a number of limitations are there because of UV light. But still, what I can suggest is, if you use the TiO2 catalyst along with use of a bentonite clay and coat onto the uh, solar panels, and then we can have this kind of CSTR kind of structure, what it has been shown. So utilizing this natural source of light, we can possible to degrade this component. So it gives around 90% reduction to in the process. So penton processes and photopenton already most of the people knows about that. along with the UV light, maybe iron sulfate or maybe iron component, it is being used to degrade the wastewater. Here, one of the limitation of this process is we generate the sludge basically, and the sludge disposal is one of the important problem. But even if you can, you can reuse that penton catalyst, then this issue is going to be solved. So in a cavitation, what I was explaining you is this is a process how it happens. Let's say this is a pump. We can have this small setup at a laboratory scale also, as well as large scale also. So the liquid flows through the, here is orifice or venturi. We can have this optimization based on the cavitation number less than 2, and then water it been recycled, and then we can come to know how much degradation is been happening. So other cases, you can have the UV light along with, these are the bottom transducer. This is processes we can scale up to 50 liter, 100 liter water also, more than that also, using the some what it is called the plunger pumps. This process can be commercially it's possible to use it. Transducer based processes, these are the laboratory space processes, so I don't want to go into detail about that. So here again, CAVOX is a process which is uses the hydrodynamic cavitation system over here. Then you have the equalization tank, and then influent coming through this cavitation process. Then further, you can add a UV source to degrade the effluent. So this is also commercially available process is there. So combined HC along with the advanced photoprinting process, we also attempted here. In this case, the photoprinting catalyst has been added. Along with that, you have this hydrodynamic cavitation, and then degradation it is going to be happen. So some of the other methodologies are there. Usually we use an activated charcoal. Because of pore size or the uneven pore size, we can have one more possibility to use a bentonite clay, which is abundantly available clay in the abundantly available clay in Indian source. So we can have the ceramic membrane module also, or maybe use the bentonite clay into bentonite clay to make the adsorption process, and that bentonite clay we can able to recycle it again and reuse it. So the cation exchange capacity of bentonite clay modify it goes to usual maybe 150 milligram per gram. So large amount of adsorption we can able to cover through this activated charcoal. So this is a bentonite clay TAME images you can see over here, and these are the basically platelet kind of a structure. So number of molecules we can able to adsorb it onto nano clay, and you can have this combination with hydrodynamic cavitation also. So this is one methodology we proposed earlier, to use this clay along with addition of a zinc oxide, and we can have the common CSTR kind of system. We carried out it at a laboratory scale level, but we can think on to the very large scale level of a water treatment. So you can see it is not possible to degrade within a single methodology. So based on that, we get an adipic acid as an outcome when the water is containing the phenol as a one component. Okay, next is I will give one example. Recently, the attempts have been made to use this hydrogel, and that is also very much useful methodology. At least 200 times expansion of this gel it happens, and almost we can have the adsorption of more than the 98% of the molecules, and we can again recycle this hydrogel to reuse. So combination of hydrodynamic cavitation along with the hydrogel, that is also possible. So these are the some of the physical appearance how these hydrogels can be used along with an hydrodynamic cavitation. Here we can have this recycled gel, with first use gel, we can go up to 6 times recycling of this polymer. Only one of the important limitation of this process is that hydrogel do not have strength structure. So for that purpose, we can add bentonite nanoclay to making this strength of a mechanical property of this hydrogel, and we can prepare the packed bed structures and we can utilize it. So other methodologies attempted was with what it is called with using this what it is called degradation of pesticides, along with using the hydrodynamic cavitations and using the H2O2 addition process. So next next one, I want to give you a small brief about how methodology can be implemented at hydrodynamic cavitation can be implemented at water lakes. Actually, in Telangana state, almost we have more than Warangal itself, we have almost 20 lakes are there. And these lakes were earlier time, it was been from the Kaktiya dynasty time, these lakes have been present. But current situation is that all the lakes have been covered with the weeds, what it is called duckweeds. And earlier the farmers were using this water for drinking purpose, for agriculture purpose and fisheries purpose. But the current condition is that all the lakes are not been useful. Some of them are currently only providing water through our municipal corporation. So we thought that can we have this work to be taken to make this water in a purified form. So we have tried at a laboratory scale level, and these implementations we are going to do it into the one lake, what it is near to NIT Warangal Bandham Cheru Lake. So we have proposed the methodology, use the hydrodynamic cavitation and along with an ozone, and it can be possible. Basically, as your bacterial growth happens in the lake, the weeds or duckweeds are going to be grow more, and that is the only major reason why the lakes have been polluting. Number of other attempts were been made through use the different methodology, but the biological growth we cannot restrict. But using the hydrodynamic cavitation process, we can have this restriction of the duckweeds. So Bandham Cheru, we have taken one lake, almost it is 138 acre land. It is been over there, and the problem is that it is in the center of the Warangal city. The what it called domestic wastewater also, hive streams have been entering into the lake, and that is again one of the important problem to why these lakes have been polluted. So this is the left hand side is the situation of a lake. You can see over here all the duckweeds have been used. People are also use this lake to be immersion of Ganesh idol in the festival season. After this, all these things, the lake conditions becomes very much poor. I will show you some data. So hydrodynamic cavitation, I told you it is very best possibility in which nucleation, subsequent growth and emulsion of cavities are going to be collapsed, and then based on the flow geometry and the different pump sizes, we can able to do this work. So, and we have carried out this work at a laboratory level, and we got encouraging effects. So first attempt I would like to want to be make it the remove all the duckweeds from the lake, then use hydrodynamic cavitation, see its effect. Then as the ozone is also very much dangerous, so we are planning to have very small quantity, maybe in the ppm level. We want to introduce this ozone in very small way to degrade this component. So this is the methodology what we can see. You can see how this cavitation bubbles. This is an orifice plate, and you have this I mean to say cavitation impingement around 6 centimeter from these orifice. So it will going to give the degradation of components. So ozone we are trying to be have very small in quantity, for a very short time at the after implementation of this hydrodynamic cavitation, which can be degrade the bacteria or virus or protozoas, and we want to make this combination. So this is earlier methodology. So what we did is we have taken these 3 different sample after the 3 different condition. Before the idle immersion, after the idle immersion, and after the treatment of cavitations, you can clearly see the growth of biological components is very quite smaller compared to these 2 conditions. So these are the data are there, COD, BOD, TDS and TS. Basically the red one shows the after the treatment, before the treatment and after the treatment. So there is large change you can observe in a COD data as well as onto the BOD data also. So this was my presentation. Fortunately, the Kakatiya Urban Development Corporation is also supporting us to this work. In Maharashtra, under the Swachh Bharat mission, Rankala Lake, you might have knowing it. It is basically the quarry lake itself. This was the earlier condition of a lake. Now you can see the children are swimming in the lake water. So this methodology is very good possible ways to treat this water, and we can utilize this for the drinking water purpose. So this is overall thing from my presentation point of view. I would like to say that these hydrodynamic cavitations, along with some hybrid combinations, we are also implementing here in one of the textile industry, along with a ceramic membrane. So that the results are also encouraging. So we have this plan to clear one lake, then take the task for the other 20 lakes to clear the drinking water from these lakes. So thank you very much, Dr. Nitin, to giving me this opportunity to present our work in the from this conference. Thank you very much. So I'm stopping.
Thank you very much. Thanks a lot, Professor Sonawane. It was so heartening to see the real-world applications, and we are so impressed that you talked about the AOP processes. Actually, the advanced AOP processes using hydrodynamic cavitation, and like these kind of processes which were at a very R&D stage just a couple of years back, now have become a mature technology, and it's so good to see that you are able to even apply these kind of technologies in the field and show that what can be happened with especially taking these kind of case studies of treating the lake water. So very, very inspiring talk, Professor Sonawane, and I'm sure this will really inspire many youngsters to look into these advanced aspects of conventional technologies. And also one very good message you have given, that we should not completely rely on one single technology and keep on improving this. It's a combination of technology, also depending on the case-to-case basis, it will work. And I personally know that you have contributed so much to the hydrodynamic cavitation or cavitation processes in general, and brought it to the level of real-world application. That was very, very heartening. So I would like to thank you very much, and I'll just quickly see if there is any question. There's one question probably for you, Professor Sonawane, if you can, if you want to answer. What happens to nutrients in lake which are the main problem?
Can you repeat it? If it is,
yeah, what happens to nutrients in the lake? Nutrients in the lake, which are the main problem?
Yeah, actually, the nutrient lake, that's why it's told that very small quantity addition of ozone we are going to conduct. And basically, there is very less change take place if you use the hydrodynamic cavitation alone on the TDS value. So there won't be the what it is called nutrition values will be as it is. Mineral values will remain as it is into the that the water is concerned.
Thank
Okay,
you so
so
much.
there won't be any much impact on it.
Okay, thanks a lot. And also, it was very important to note that these techniques or technologies are low cost because we are using quite a low cost materials like bentonite or intercalated clays, as well as these are energy efficient, which is usually a question or
Yeah.
challenges when we talk on the adaptability of these methods. So thanks a lot once again, and thank you very much for sparing time, and we can have further discussions at the end of the session. Thank you so much. So you can please
Thank you very much.
unshare your slides. Thank you so much.
Okay, okay, sir. I will unshare. Okay, sir. Sir,
Now,
slide unshare कशा करायचं इकडे? हाय. Slide unshare कशा करायचं?
Sir, we'll go to the next presentation by my own colleague, Dr. S. Saravanadevi. Dr. Devi is currently working as a senior principal scientist at the Health and Toxicology Cell. And he is an expert in the human genetics and the health risk assessment. And all of you must be aware when the winter comes, we start talking about that this is the morbidity and mortality due to several air pollution episodes, especially in a country like India. And this is a very, I would say, very complex issue, not only in terms of estimating the health burden, okay? This has direct relation to our country's image. That's number one. And number two, for planning the control strategies, okay? So this is a very, very critical area where Dr. Devi has been very, I would say, sincerely studying for last more than 2 decades. So as far as her credentials, academic credentials are concerned, she is a PhD from Nagpur University and a master's in biomedical genetics from Madras University. She did her postdoc studies at the Rudolf Böhm Institute of Pharmacology and Toxicology, Leipzig University, at Leipzig, Germany, on molecular epidemiology. She has more than 95, close to 100 papers to her credit. Dr. Devi has published in wide areas of health and environment, as I already mentioned. She also has a couple of patents, 3 patents for her credit, and many students I can see that she has guided. So Dr. Devi is breaking this very critical topic of health environment correlation. And with these few words, very good afternoon, Dr. Devi, and thank you very much for being with us. And I would request you to please go ahead with your talk.
Thanks, Dr. Nitin, and I sincerely thanks ISIS for giving me an opportunity to speak on this topic. And can you hear me? Hello?
Yes,
can you hear me?
Yes, I can. Yes, yeah. Very clearly.
Okay, I'll share my. Can you see the slides, please?
Sure, you can go to this PPT mode.
Yeah. Now I'll be talking about the microplastics abundance in the environment. So if you see plastics, you all are aware, they are very useful, but they are persistent and transboundary pollutant. They exert a lot of negative impacts, like ecological effects. Mostly it reduces the aesthetics and it increases the cost for the management. And it also causes the toxicity, which includes reproductive toxicity, carcinogenicity, and mutagenicity. If you see in the environment, the plastics are further degraded into more harmful substances, which is difficult to remove. These substances are called microplastics. They are, since plastics are persistent, this microplastics are also persistent. They are semi and synthetic heterogeneous plastic particles which are lower than 5 mm. These are intentionally manufactured as micro-sized particles, or they are formed by the degradation of plastic products. They have various shapes like fragments, fibers, microbits, and nodules. The information about the prevalence of microplastic in the environment is limited, especially in the Indian scenario also. You can see how the microplastics are formed in the terrestrial as well as in the water system. So depending on the origin, they are classified into primary microplastics and secondary microplastics. Primary microplastics are deliberately created in microscopic size, like microbeads, which we use for the runoffs. They are all released from the cosmetics, personal care products, synthetic clothing, and insect repellents, etc. They are dominating in the wastewater effluent system. And globally, around 1.5 million tons per year of primary microplastics are released in the ocean, of which 98% is through land-based activities, and the remaining is through ocean-based activities. Secondary microplastics are is a breakdown of larger plastic particles in the environment. They are formed by different ways like thermal degradation, phytodegradation, hydrolysis, and biodegradation also. They are particularly abundant in the open ocean. So if you see the environmental issues of microplastics, you can see here they can choke the drains and they reduce the aesthetics, and in the terrestrial things, it causes infertile land. It accumulates in the system, and it also accumulates in the biotic system, where through ingestion it accumulates in the body, and it is reported to cause the climate change also. The global prevalence, if you see today, general studies regarding microplastics have placed emphasis mostly on the marine environment. A little concern is given in the soil environment, while the airborne microplastics are still very limited. If you see aquatic prevalence, around 15 to 51 trillion microplastics weighing between 93 to 36,000 metric tons are estimated to be floating on the world's ocean. This is 2015 report. And in the terrestrial system, terrestrial system is more vulnerable to microplastic contaminations. They can be transported into the deep soil by the activity of soil microorganisms. Their contamination is about 4 to 23 times larger than the ocean, and agriculture land store more microplastic than the ocean basin. This is also 2015. If you see atmospheric prevalence, since this is not well studied, in 2017, some researchers identified microplastics in the atmosphere, both in indoor and outdoor. This was also confirmed by other researchers who reported that the microplastics can be transported in air in different forms and shapes. Now, this is a study carried out at NEERI by us. This is the quantification and characterization of microplastics from the roadsides of Nagpur city. This is focused on the quantification and identification of microplastics in the PM10 and PM2.5 air particles at Nagpur. The sampling was carried out in the residential area, dump yard, commercial area, and industrial area. These are the places where we have monitored the PM10 and PM2.5. So, if you see this, the organic contaminants of the PM2.5 and PM10 particles were removed, and then further it is extracted and all, and then it was identified by different methods. Like the samples were viewed under stereo microscope, and then the presence was confirmed by the Nile red staining, and the morphology was also studied using the scanning electron microscope, and the chemical characterization is done with the FTIR. You can see the stereo microscope photograph of PM microplastics in the particulate matter. This is the Nile red staining of this, indicating and confirming the presence of microplastic in the air. This is the electron microscope picture of this one. It has grooves and all. These grooves can able to accumulate the chemicals present in the atmosphere. This is the FTIR spectra of all those things, and you can see the high low density polyethylene, cellulose, and low density rubber fibers and all in this FTIR. In a summary, we have identified an average of abundance of 50 to 120 microplastic was observed in all the 4 urban areas of Nagpur. And the FTIR results showed low density polyethylene, rayon, rubber fibers, polystyrene, polyaniline, and chlorinated polyvinyl chloride in the samples. The residential area was dominated with cellulose fibers, mainly the rayon fibers. This is mainly due to clothing and textiles used. Dump yard site showed low density polyethylene, and commercial area showed car paint chips as primary particles. Rubber fiber also was there. And as I told you, like SEM was showing the grooves and fractures on the surface of the microplastics. You see the impact of microplastics in the environment. See, in the water environment, you can see the weathering of microplastics, which in turn consumed by the fishes, and then it accumulates in the plants, and how the fishes is consumed by the human, and how this is affecting the water system. So this is the one, this is health effects of microplastics, how the microplastics are getting into fishes and how it is getting into us. This is the pampered fish, this is the elite fish, and this was collected from the market. We have screened the microplastics in the flesh, gut, and everything. And you can see the microplastic in the flesh of the pampered fish. So if you see the effect of microplastic on human, the exposure can occur in human by 2 ways, like by ingestion or inhalation. And by ingestion, you can see there are many microplastics people have identified in several human consumables like beverages, table salt, honey, beer, and tap water, bottled water, and various seafoods. And Catriona et al. 2018 reported the consumption of about 4,620 microparticles per year per capita in higher shellfish consuming countries. The aerial presence of microplastics is through the inhalation. People are getting exposed. They can induce the localized particle toxicity, as well as it can induce the chemical toxicity by leaching of absorbed particles. And the daily exposure of aerial microplastics were about 97 to 132 MPs, which accounts for around 35 to 62,000 microplastic per person per year. This was reported in 2019. But in our case, we have found around 50 to 120 particles per day in Nagpur city. The adverse effects of microplastics are, although they cannot induce acute toxicity, but they can induce the chronic toxicity through the inhalation and ingestion. Several in vitro studies have shown that they can induce inflammation and oxidative stress. When you inhale, they can induce the respiratory lesions, which in turn, the lesions can in turn induce the inflammations. And during the inflammation, the oxidative stress can occur. It can cause the cell death and etc. This is in a small, in a chronic exposure. While in a sustained exposure, it can causes the liver lung damage, which can induce fibrosis as well as carcinogenesis. In the aquatic environment, the MPs are ingested by the marine biota, which can lead to trophic transfer. They can damage the fishes. They can induce metabolic disorders and inflammation, suppress feeding activity, growth and reproductivity, which can induce the economic loss of the country. In the terrestrial environment, microplastics can affect the biodiversity, alter the soil properties, which in turn cause the infertile land, and they can cause the toxicity into flora and fauna also. So as you know, like this MPs can also absorb pollutant. They can also result in the chemical toxicity. So preventive methodologies, how can we prevent the microplastics? As you all know, like reduction of plastics is one method. And the other method can be, we can use bio-based plastics as an alternate for the conventional plastic. This is also being done in many countries. In the United Kingdom and New Zealand, Canada, they have banned microbeads in the rinse of product like, mouthwash and hair wash. Such things, microbeads are used. Now they have banned that. Around 170 countries in United Nations Environmental Assembly have planned to reduce the plastic consumption by 2030. There are several, although we know many things about the plastics, so microplastics, there are several lacunas like insufficient information on the pollution source, unsatisfactory data on MP microplastic pollution, no prioritization of mitigation method, etc. This needs to be addressed while taking care of microplastics in the environment. How can we remove the microplastics from the environment? This is very challenging because of its minute size. Several studies are now focusing on this subject, especially from wastewater treatment plant and sewage sludge, as they are considered as a primary source of contamination. There are many methods have been adopted, like skimming, tertiary filtration, and sedimentation, which can remove the microplastic from the wastewater treatment. Bioremediation is also one of the important area of research, although they are not fully studied. Due to the as microplastics are non-biodegradable, and bioremediation is quite difficult. However, some of the studies I've conducted last few years, they show that some of the bacterial and fungal enzymatic degradation of microplastics can be a tool for the promising degradation. Bacillus species isolated from the sediments of mangrove from the peninsula Malaysia is reported to hardier, colonize and degrade the microplastics, and fungus is also reported to utilize polyethylene from the microplastics by reducing it. Bioremediation is still an early stage with slow rate of degradation being the main challenge. So the other one is microplastics still needs exploration in terms of standardization and harmonization of protocol for the quantitative and qualitative analysis of complex environmental systems. And we need to have a guideline for accurate identification of microplastics so that the risk estimation for the human or the animals can be taken care of. Most of the studies conducted so far is on the aquatic contamination. Now we need to concentrate more on terrestrial and atmospheric settings. Further investigation is required to the toxicological and to understand the toxicological and ecological effects of microplastics, because most of the studies on in vitro system on microplastics toxicity cannot be carried out because the microplastics cannot be dissolved properly. So there are many failures in the toxicological observations. This should be addressed, and the management protocol should include strategies to reduce the introduction of plastics in the biosphere. A specific method should be adopted to treat the primary and secondary microplastics and need to prevent them from reaching the ecosystem. Thank you. Hello.
Yeah, thank you so much, Dr. Devi.
Oh.
And before I comment, there are at least 2 questions we can probably pick up if you have time. First of all, thanks for a very, very informative talk, and for sensitizing us that the microplastic has already become an emerging pollutant, and also doing this kind of a pioneering studies in terms of Indian context. Okay, and also bringing it scientifically that what could be the ways of its exposure, especially the airborne, was quite interesting. And we can understand that, yes, it will be the particle toxicity as well as the composition or chemical toxicity. Both can come from microplastics. So thanks a lot for that. And we can probably take up 1 or 2 questions.
Thank you.
Mr. Anil Jain is asking, what is the percentage of microplastic generally found in PM 2.5 or PM 10, if there is any data? And how these microplastics interact with other particulate matter present in the environment. Right.
See, that could not be identified because the if you see the particulate matter, that needs to be, usually we will do the weighing the substances. But here we need to remove the organic content of this in the paper. And then we have counted them in the with the stereo microscope. So actually, we could not do the percentage of microplastic on the particulate matter. That was the problem. That needs to be established further.
Yes, and you already used some IR techniques to reliably study in a, I would say, qualitative way for the presence of microplastic.
Qualitative, and quantitation has to be done because you really cannot see the particles in a naked eye. So you have to see it in the microscope. So that is why we were not able to do that in the particulate matter. Yes. In future, we will try to do that.
Of course. I think your talk has generated a lot of interest because we have about more than 100, about close to 120 participants on this Zoom link, but then there are equal or more number of people on like the Facebook. So I think for the want of time, I request all other people to kindly interact with Dr. Devi. Her email contacts are there, and then we'll have a little more opportunity while all the panelists will give their brief remarks at the end of the session. So Dr. Devi, thank you so much for enlightening us on this very emerging and a very serious problem, and thanks for accepting our invitation. We really thank you.
Give me an opportunity. Dr. Nitin analysis.
So we will now move to the next and concluding your last talk of this session, which will be by Dr. Sandeep Mudliar. And it's indeed my pleasure to introduce you, Dr. Sandeep Mudliar, who is a brilliant chemical engineer. He's working as a senior principal scientist at CSIR Central Food Technological Research Institute, Mysore, and had earlier worked with CSIR-NEERI and Praj Industries, Pune. He has got an excellent exposure of many chemical processes. He's done his master's in chemical engineering from prestigious ICT Mumbai and has completed his PhD from NEERI in the area of high performance bioreactor for pollution control. He was also awarded the Raman Fellowship to pursue research studies at very famous Duke University, USA. also received advanced research trainings at different countries, including UK, Japan, IC Bangalore, IITs, and many other labs. His research interests are quite wide, as I understand. Of course, few of the research areas are development and demonstration of technological solutions for pollution control, sustainable AOPs for wastewater treatment, emerging pollutants, secondly, life cycle assessment, which we just discussed in first talk, modeling alkaline plant cell biology to high value food product, to just name a few. Over 100 publications to his credit, US patent, but he's also very well known for the field-based solution or real-world solution provided. So, Dr. Sandeep, it's indeed a pleasure to have you with us, and I would like to request you to please go ahead with your talk.
Good afternoon, all of you. Am I audible clearly?
Yes.
Okay.
Yes.
Is my presentation visible?
No.
It's just appearing, probably. We'll hold on.
Yeah, yes, yes.
Yes, it's coming.
Yes.
Please go for presentation mode. That's perfect.
Okay. So, good afternoon, everybody. Many thanks for the opportunity. I hope I'm audible clearly. I'm not using the mic.
Yeah, you are quite audible.
So, since the theme is on, I will straight away come to the practical problems which you are facing. So, I will just start with a statement. All the speakers were speaking, if you take any of their food item and see for pesticide and bacterial contamination, you will find 70% of that. So, daily all samples which are coming to CFTRI, we are detecting all type of conventional contaminants. So we thought of doing some research on this emerging micropollutant and what you will do for your own institute, because being an R&D institute, we release a lot of micropollutants in the environment. So the topic of my talk is emerging micropollutants in the environment and its nexus with food and health. Because generally, food institute is generally assumed to do very simple work. But after coming here, I thought ultimately if safe food is there and you link the nexus between pollutant, environment and health, that is how my interest in this topic came. So as you can see, this is a classical paper which came in EST. The carrot is contaminated with an emerging pollutant known as triclosan, okay, which you are using in the hand washes, especially in COVID. And you are daily using lot of personal care and pharma products. So ultimately it will be uptaken by those plants. So what is the uptake? What is the toxicity? What is the health concern and what are the solutions? So I will try to cover in the talk. So you can see these were the goals to be met by 2015 under Millennium Development Goals. You can see goal number 1 and goal number 5. It is related to health. So ultimately, the final manifestation is on your health. So 2015 is over. So this we are supposed to by 2030. You can see goal number 3 and goal number 6. 3 is good health. 6 is clean water and sanitation. So there is a nexus between these two coupled to climate change. So this all and goal number 7. So I will be talking the nexus between goal number 3 and goal number 6. So these are some recent reports. Presence of pesticides. This is all last 1 year reports. And this is the daily chemicals which is used: soap, shampoos, lipstick, perfume, nail polish. So I will not go into details. So number of emerging pollutants are likely to come because of use of these personal care products. So I have named the chemicals which are likely to come. So all this will find its way into sewage. I'm now restricting my talk to the emerging pollutants in sewage. So what is the concern? Conventional municipal plants will not treat this emerging pollutant, and already we have a burden of pesticides. Okay. So are you able to see this slide?
Yes, yes.
So the common use is UV sunscreen. So these are, and antibiotics which are used. So number of personal care products are used daily and antibiotics So this will all find their way into sewage. So this is a classical paper which came recently. Ultimately, human medicine, veterinary medicine, it will finally find its way onto agriculture land and finally will be uptaken in the food chain. So this is a recent paper of pesticide problems. So I will skip this. This is even in Vidarbha, you can see the maximum pesticide should be less than 0.5. You can see the concentrations. I skipped this also. This is my own state of Karnataka. So this is just 5 kilometers away from CFTRI. You can see the limits of pesticide. But coming, pesticide is well studied. Coming to the emerging contaminants like pharmaceutical products, you can see India, very limited reports are available. You can see it is about 1000 nanogram per liter. So this I'm giving the best case scenario of a STP in Spain, because very limited and which is having primary, secondary and tertiary treatment. You can see about 66 micropollutants are detected. So mostly antibiotics, okay, inflammatory compounds and personal care products. So you can see carbazepine. India is the largest manufacturer of carbazepine. So we are getting about 100 times more concentration in Indian waters. So this is some of the seed. This is the CETP in potentiary. You can see the range of antibiotics. So we have limited knowledge on emerging micropollutants in water. So very few reports on the health aspects are there. So this is where how it will be uptaken and will cause damage to the body. So these are some very good papers on conventional crops on micropollutant uptake. So you can see rice and apple, the micropollutant uptake is very high, up to 10 milligram per kg. Okay. So even if you substitute conventional pesticide with next generation pesticide, at the same level, you can reduce the toxicity. Okay. So I will move further with this case study of these 6 micropollutants, which are very relevant to Indian condition because India is the largest manufacturer of carbazepine. And triclosan, in spite of the ban, we are continuing to use it, especially the it increased during COVID. And India is also the largest manufacturer of other drugs like diclofenac and others as listed. So these are the physical properties. So as a model, I will explain triclosan. It is used in number of products, and in 2013, FDA indicated a lot of companies to come up with very concrete evidence because it was designated as a contaminant of emerging concern and a potential carcinogen. So this is the uptake in plant. You can see carbazepine up to 50 milligram per kg, triclosan up to 3.5 microgram per gram. This is in various plants, various pharmaceutical compounds. Okay, so it is able to transfer the cell membrane barrier also. So this is the concentration of these compounds in root, leaves, and this. So you can see carbazepine presence in lot of plant parts. Okay, and this is one very surprise finding. There is also formation of more toxic metabolites in plant like 10, 11 epoxy carbazepine. So if you put carbazepine to plant, so India is the largest producer of carbazepine. So there is a chance of more toxic products inside the edible plants. So recently we started a full-fledged research on this. So you can see the bioconcentration factor in roots. So the top compounds are triclosan, carbazepine. This is soil in the soil. So you can see the bioconcentration factors of carbazepine. You can see in the pore water, in the radish bulb, radish leaf. Okay, so the carbazepine and triclosan are widely found. And hardly any Indian data is there in plants So recently CFTRI started in its own small way through PhD programs. So you can see what is the danger. Triclosan, if you eat 159 gram of radish daily, okay, you can cross up to 83% of the average dairy intake. Okay, so two compounds, carbazepine, okay, was detected in carrot roots, okay, and also in potato leaves. So health risk was noted. This is all secondary literature. Okay, so coming to the human exposure, all the data is available to a limited extent with limited pollutants in the US scenario. So I have given the numbers, how much. So in Indian scenario, since our sewage is treated less than 25%, the contamination levels are likely to be much higher because we have almost all types of micropollutants presence in sewage. So what was the future research need? Conventionally study the micropollutant uptake is various plant, do field measurements, okay, do a comprehensive environmental impact assessment, okay, that is all fine, we can do it. But immediate is, especially in even a small city like Mysore, 75% of the sewage people are using to cultivate various type of fruits and vegetables. So our initial study indicated huge amount of micropollutant. So the only option was to develop technologies which will kill or which will mineralize this micropollutant in sewage. So the only option for this is advanced oxidation technologies. I will not go into details. Our earlier speaker has given what are AOPs. So there is a very good study. AOPs can degrade all this pollutant, and the big scale study was done comparing TiO2, solar, ozone in a real full-scale plant in Spain. So with that in the background, we started our studies. So these are all the literature data. So I will come to what we have done in CFTRI, because we had an ETP which was treating our industry, our lab effluent. So since this lab effluent, all types of micropollutants were coming. And as per the regulatory norms, we were supposed to bring CO2 to less than 50. Okay, so this was launched last month, but we were running this plant for more than 2 years now. This is a full-scale plant, 100 KLD with advanced oxidation process. So this technology now we have validated for sugar distillery, pharma, textile, for wastewater at 100 liter scale. So initial validation is to reduce the COD and color up to 50. Plus, we are analyzing all the antibiotics and all the pesticides because those standards are available at CFTRI, and that is the conventional use for drinking water quality assessment. So we are monitoring this STP as per drinking water standard for all the heavy metal, pesticide, and antibiotics. So this advanced oxidation system can also be used as a pre-treatment option, post-treatment option, as well as standalone plug-and-play option, especially for the apartments where new norms have come. All apartment has to have their own STP. So these are the publications which came out of that. So this is a 120 KLD plant retrofitted with advanced oxidation process. And this we are also monitored by the pollution board thrice a year. So earlier this plant was not working. So we have modified it with advanced oxidation process. Fully technology is indigenous, and this plant is monitored for 28 parameters, including pesticide, antibiotics, and heavy metals. Then to scale up this plant, lot of interest was there from lot of apartments and food industries, because in food industries, even if you are using any chemical in the STP or ETP, there are some export concerns. Okay, so for that, with after 100 KLD scale, what will be the scale-up correlations? So we developed the entire Venturi loop reactor technology, where we ensured efficient absorption of AOPs. Ozone was one of the chemicals used. Then we did CFD modeling. Then we applied all the scale-up rules. Okay, so I'm also happy to indicate that once in a decade such type of book comes from India. So this is one of the very recent books, originally work done in India. So we using this book and with the Professor Pangarkar's help, we scaled up this system so that how the system will behave from 10 KLD to 1000 KLD scale. So these are our test reports. This is from the Codex lab of CFTRI. Codex means we are accredited to international agencies. So this report is valid in 166 countries. You can see the detection of phosphorus pesticides. Okay. All heavy metals also we are saying. So now recently we are upgrading this to our health center effluent. This is a small plant. So you can see these are some new standard for the STP. So because of this, we got lot of queries to destroy this micropollutant plus meet the emerging COD regulations in apartments. So now the system is under implementation in 2 apartment complex. So this is so even in a 200 apartment complex, if everybody pays 5,000 rupee one-time fee, whether it is a new apartment or an old apartment, we can meet COD of less than 50 with practically 70% micropollutant removal. But our micropollutant analysis now is limited to pesticides and antibiotics. But we are very sure that we can degrade triclosan also based on the secondary literature. This other study we did, where the well was contaminated. So this was the requirement of the board. So we also showed that this is the only solution to remediate the underground colored water. This is contamination about 5 kilometers of land. And why we could do this? Because we had very good analytical facilities for 45 pesticide and antibiotics. That's why we were able to do this. And we are using all these AOPs and better oxidation in food industry. Because food industry requires chemical free approaches. So because of that and very good analytical facilities, which I felt is a backbone in environmental sciences now. So we routinely monitor antibiotics in food and water. So that was used to monitor the ETP. So we also do a lot of fundamental analysis in FTIR, GCMS, LCMS, while developing food products, especially next generation food products for lifestyle diseases. So all those equipments we are trying to use in environmental sciences now. So we are also using life cycle assessment because we are also ISO, probably the only laboratory who has ISO 14001 standard. So this was compulsory in the institute as well as all the technologies originating from the institute. So these are the papers on life cycle assessment which we could publish. So thank you very much. These are some of the publications on which the technology is based. So I conclude here and thank you very much. Thank you. I will be happy if there are any questions.
Thank you so much, Dr. Sandeep Mudliar, for an excellent overview of PPCPs. And as we all know that personal care products are becoming a threat, and this was sensitized about a decade back very seriously, but there is no respite. And this is further adding to the pesticide problems we already have in our country predominantly. So emerging pollutants, especially the micropollutants, are definitely very challenging, but it was pretty heartening to see that at the CFTRI lab, using a state-of-art facilities, you are not only able to determine the presence as well as quantify the presence of at least quite a few micropollutants, but you are able to demonstrate that there is a good possibility of controlling this up to the level of 70%, and especially that the cost estimates are quite doable. So things are very scary when it comes to the micropollutants. We can make out from your talk, but thanks for also sharing that if we ramp up our conventional sewage treatment plant facility or wastewater treatment facilities, that itself will take care, and there are very good possibilities to use the advanced processes as we just seen through you. So with this, we have come to the conclusion of the talks. May I request all the panelists to please switch on their video cameras so that we can have a couple of minutes of a quick discussion, and then I would request all of you for a very brief message, maybe 1.5 minutes to 2 minutes. So thanks a lot to all the speakers. It was really, really fantastic, and I would say it was so well structured talk that within such short time, you could convey your message very strongly and very clearly. So on behalf of the society, which is International Society for Energy, Environment and Sustainability, as I understand, I'm a part of this society that we promote the interdisciplinary interaction, which has not important but have become actually mandatory or absolutely necessary to resolve most of the issues, whether it is energy, environment, or sustainability. I'm especially happy with all the speakers to bring about very, very recent issues related to the environment, as well as the very recent updates and the possible futuristic areas, and at the same time giving references to the real world solutions. Okay, sharing some of the case studies where you have shown that it is possible to economically handle the environmental challenges. So I would just see if there are any additional questions in addition to what we have taken up. There's one question for Dr. Devotta from Mr. Shiva Subramaniam V. Whether algae-based system installed at SNAP Ranipet and Titan in Hosur, SNP Dr. Devotta has visited. Your comments, sir, on these systems?
See, most of the systems, they do have their own problems, because operation of membranes and multiple effect evaporator, they're not the ETP operators are not that familiar, because they get clogged if you don't operate properly. If you don't pre-treat water, it damages. And multiple effect evaporator, if there is a power failure, immediately you have to take care of the draining the solution and clean the solution. Otherwise, you can't restart it. Multiple problems are there, and that's why in the unit I was referring to, now they have put a 5 megawatt solar power generation so that they get uninterrupted. They have genset, but genset is too expensive, so they have put a 5 megawatt so that they can operate the unit without power failure. So they have a switchover mechanism, so automatically. So always there are problems. Cost of membrane replacement itself is very challenging, because membrane get damaged if you don't treat the system properly, for particularly RO. And the other thing is, I told you about inorganic chemistry. You need to work with inorganic chemist on the solubility. Sodium sulfate and sodium chloride, they are mixed salts with organic salts, and you have to purify one of them, which is sodium chloride. So how do you purify sodium chloride in situ? You can do it, you can purify it, no issue about it, but at what cost? So purifying it while being separated is the inorganic solution. So solubility problem. So like salt solution, if there is, I've been suggesting, but still we have not come out with it. And if there is no technology, there is only one technology available, but he is asking for a cost of an whole plant. If I have to put that technology, I have to pay him the entire plant cost to him. So that's why we need Indian-based solution instead of getting the salt out and then solving it. No, that is not sustainable. We have to do it in situ.
That's right. And the cost of the product like salt is so it's such a low cost product that you can't afford to do that.
So yes. But if I have to dispose it, I have to pay 3,000 rupees per ton.
Very true. Yes. Thank you so much. So since we do not have any questions, I think so, and as I have requested a couple of people, because probably we have now more than 200 or 250 people joining, so they can directly contact the respective like speakers. So before we conclude, since we have a wonderful panelists together here, I would request each of you to give a 1.5 or 2 minutes message, especially to our youngsters, about what could be the future, whether you feel we have to try preventive more than the treatment processes, okay, go for preventive methods, or whether we need to change the lifestyle, or third thing you can touch upon either of these things, that what are the prospects for the research or as a career. Very quick 2 minutes. So I'll start with again Dr. Devotta.
Yeah, if you're doing any research, you should focus on salt-laden wastewater. That means high TDS of the order of 30,000, 40,000 minimum. How do you treat that wastewater biologically? And for instance, people have been talking about using ozone, because you can't put air and get dissolved oxygen to the extent required at that high concentration. With high concentration of TDS, the dissolved DO reduces. So you need to promote concentration. How do you do that? People have been using in our own in this system. They have tried ozone. Then they have tried liquid oxygen. Today they are using liquid oxygen because and therefore they produce oxygen in situ and use it. So you need to think, how can we do degradation of organic matter under high TDS? So this is one topic. Second is, what are the ways and means of reducing effectiveness of ways and means of avoiding the blockage of membrane, RO, particularly RO. Whatever you do, pre-treatment, because it contains some organic matter also, so therefore they put organic scavenger, and it still contains some color. So when you take salt, you get colored salt. So how do you reduce the color? How do you reduce organic salt in the solution at a reasonable cost factor? So this is another, so that RO goes through and you get salt, reasonably colorless salt. People will say our salt is colorless, but I can tell you, if you take real wastewater, you get a little bit of color. Last is inorganic. I told you, you need to resolve salt purification. Without that, and this is not just unique to leather. It is this problem is prevalent in pulp and paper, sugar and distillery, textile, and leather. So at least 4 or 5 industries, which are major industries in India, they have this issue on leather. That's all I would say.
Thank you very much for the words of wisdom. I would say these are not only important for the youngster, for all of us like a professional researcher. Thank you very much. We'll now move to Professor Kashyap. If you have few brief comments, and I can understand being at UK University, there must be many people approaching you that what should be the like areas of research. Many of they cannot join you, but at the same time in India, in Indian context, since you are working in the urban environment area, what are your tips for them?
Yeah, sure. And let me get back to my message in the PowerPoint slides, actually. And the core of the message is, means I come mainly from the policy background, which is more like environmental policy and how things can go progress. And I'm not an hardcore scientist like other panelists, but I can always see the direction of travel and where it can make more sense and more integration at more strategic level. That's where my more strength lies. So heading a department in the UK university here, I can see the multidisciplinarity of applications. So most interestingly, I have found, and I can make some linkages here with the environmental scientists, which I have got in my department. They work across the various specialism. For example, one of my colleague works on use of machine learning for pesticide applications in the crops. So the machine learning and using the drone, basically, which earlier you were mentioning that it has become quite prevalent in India and useful in India as well. So what one of my scientists has done is devised machine learning platform and mounted it on a drone and identifying the only the weeds, and then the spray of the the pesticide on the targeted plants only, rather than spraying it everywhere. So that is, it's an use of machine learning the outside the applications. And that's one thing which is going on. Then microplastics as well. One of my colleague is working on microplastics which are available in, which are prevalent in air. And we are using some sort of machine learning use of artificial intelligence in actually analyzing the composition of those, and even we using the spectroscope and having some sort of mapping of the characteristics of those microplastics of prevalent in. And this is quite a huge problem these days, which is in water or in various appliances, etc. we use. Likewise, there are multidisciplinary approaches which are going on. So it's my key message here to researcher is that this is not a standalone area where you just do yourself, but involvement of other skill sets as well, and you collaborate with the people with other skill set, and that's where the progress will be made more effectively, rather than, and this is a add on to the traditional way of continuing our lab work, etc. But the things are changing. So use of technology, use of data, big data, and how we can actually then go forward more rapidly in suggesting some solutions is very much required. So that's the key message, Dr. Labhsetwar, I'm trying to give it to the audience.
Very much. Thanks a lot, actually, because these are the areas where things are moving fast, and people they are opting for these kind of domains, whether it's data science or AI. But they often do not understand that probably AI can be so effectively, so efficiently can be used. So as the application of drone, although we started at NEERI. So thanks a lot, Professor Kashyap, and I truly admire you that during this vacation time also you could find time to spend with us and enlighten us with so many things. So we are almost running out of time. So what I would request Dr. Sonawane to quickly give one or two comments, and then we can go to Dr. Saravanadevi. Dr. Sonawane, please.
Sir, yeah, thank you very much, sir. Actually, related to textile wastewater or other chemical industries, basically, we never saw at what sewers it is, how in the sewers it is been generating. So we can use some process intensifying equipment so that effluent can be properly been treated. I mean, the number of streams are coming. For example, currently we are working with one industry. So they have the washing area is different. Then dye processing on the cloth is different. And then they have the different dyes again. And again, final washing, like three are there. And all this water, they are making it combined, and then we need to be treat. In place of that, see that whether we can have separation of a stream, it will become easier to treat the wastewater. This is first experience we are doing it now. But I think just need to be solve the problem at the source itself. It will make it more useful. That's why my message is here.
Yes, we need to go for the preventive things. Otherwise, there has to be some footprint, whatever end of pipe treatment we try for. Thanks a lot.
Right.
May I request Dr. Devi to quickly give?
Yeah. See, the microplastics, whatever we had a talk today, like, now the microplastics can be seen in Arctic regions also. Now we have to identify what is the origin of this microplastics and how they are moving towards that. That needs to be addressed. And in a toxicity point of view, also, we do not have any reference standard to identify the health risk. Like for the pesticides, for other chemicals, we do have a reference standard where the level is safe. For the microplastics, we do not have such a reference standard. This needs to be addressed so that in future we can do the risk assessment as well as the treatment procedures can also be adopted. This is what I want to say.
Okay, thank you. Yes, it was quite scary to understand that it has already become a part of like the particulate matter. Okay, so it is a part of particle matter. So obviously the dispersion is going to be exponential and it is reaching everywhere. Thanks a lot, Dr. Devi. Dr. Sandeep, for your quick one or two comment. Dr. Sandeep, you are still muted. Hello. Yeah, we can't hear you. You are unmute, but we can't hear you. Some issue with your connection, probably. No, I can't still hear you.
Hello.
Yeah, now it's better.
I will just share a concern. See, research and all is okay. Since I had around a background after coming here, the major concern is we are having huge population. We don't have treatment and we are using chemicals as in. So the immediate concern is sewage is used for all even Mysore is a cleanest city, 75% sewage is used. The STPs don't work. So these STPs came to India when Maruti 800 came to India. So you require modern technologies. You cannot put technologies with simple activated sludges. Second is sustainability of this technology. Okay, so you should use very advanced tools of life cycle assessment. Okay, and see, the SDG says partnership for the goal. And third most important is we require quality students who can take big research problems. So the relevance of the problem in research, the methodology to solve the problem, and the tools to solve the problem. Especially engineers should use all types of tools to the problem. So my personal experience was there. If I use advanced chemistry tools like GC, GCMS, LCMS to understand the problem, use advanced chemical engineering technique as well as sustainability techniques of life cycle assessment, and you take into advanced structured standards like ISO 14001. Every word in the standard has a meaning, provided it is taken and you partner with everybody. And first is set your own house in order. For example, if you are staying in an apartment, you are working in an R&D lab, find out where these chemicals are going.
Dr. Sandeep, I got a warning that another 1 minute, it will be automatically, link will be closed. So what I'll do, I'll just take 30 seconds and then again hand over to you. In fact, on behalf of the society, I would like to profusely thank all the 5 speakers for sparing time and for such a brilliant and updated presentation as well as discussions. At online platform, as we know that we can reduce a lot of carbon and environmental footprints, so that's always a good idea. But in future, we would like to see you personally and host you. Also, I'm so thankful right from Dr. Sandeep to Dr. Devotta to highlighting real world problems, how to solve it, okay, and also highlighting the importance of minimizing the need, okay, as well as the partnership. So this is very I would say resourceful as well as valuable inputs from your side, okay. And I would like to profusely thank on my personal behalf and on behalf of the society for accepting our invitation and making this session very lively and valuable. I think we are on a more or less informal platform. So Dr. Sandeep, you can still take 1 minute and go ahead and then we can add. Absolutely no problem.
See, my whole concern was first, we have to demonstrate model labs. Okay. So if I will give you an example, if you have an environmental department and your university is not treating the waste. Okay. So that is one concern. If you run an apartment where the wastewater goes,